Hello learners, this is Education Online program. I'm Teacher Lily. I'm going to teach you chemistry, and our topic today is the chemical properties of group 2, and this topic is for senior 3 and 4. So learners, what is this ionization energy? So ionization energy actually is part of the physical properties of group 2. So ionization energy is the energy required to remove an electron from a gaseous atom. So when there is removal of electron from an atom, then we say that ionization energy is responsible for the removal of the electrons. So we are going to say that ionization energy in group 2, it decreases from top to the bottom of the group. So it means those elements above in group 2 are having higher ionization energy compared to those ones below in the group. So as you move from top to the bottom, the ionization energy decreases. So we have to put this down by saying that ionization energy is the energy required. Ionization energy is the energy required to remove an electron from a gaseous atom. So here we are going to say that the alkaline earth metal or group 2 elements, they ionize by losing the first element and then the second, the first electron and then the second electron. So it means here when these elements or one of these group 2 elements ionize, they lose the first electron in its atmosphere, then followed by the second electron. So when it loses the first electron, we say that this is first ionization energy. So the energy required for removing the first electron in the outermost cell of any alkali earth metal or group 2 metals, we say that this is the first ionization energy. So while the second energy that is required to remove the second electron from any group 2 element, so we call that one as second ionization energy. So we are going to say that this ionization energy here in alkali earth metals, the alkaline earth metals ionizes by losing the first electron and then the second one. By losing the first electron, then followed by and then the second electron. So here we are going to say that the first energy needed to remove the first electron, we are going to call it as the first ionization energy. So therefore the first electron, therefore the first energy required to remove, therefore the first energy required to remove the first electron. So let me say the energy required, therefore the energy required to remove the first electron is called the first ionization ionization energy. It's called the fast ionization energy. So here we will refer to it as the fast ionization energy. So therefore the second electron which is going to be removed after the first electron, we are going to refer to it the energy, we are going to refer to it as the second ionization energy. So while the energy required to remove the second electron is called, or is known as the second ionization energy. Second ionization energy. So here we are going to say that there is first ionization energy, second ionization energy, and even it may go to the third ionization energy. So it depends on the number of the electrons that has been removed from an atom or an element. So we are going to say that the ionization energy decreases here in group 2. So ionization energy in group 2, ionization energy for group 2 decreases from top to the bottom of the group. From top to the bottom of the group. So we are going to see that the ionization energy decreases as we move from top to the bottom, and we know that the first element in group 2 is known as beryllium. So it means beryllium will have the highest ionization energy compared to magnesium, and then magnesium will have high ionization energy compared to calcium. So we are going to see that this ionization energy decreases as we move from top to the bottom of group 2. It means the element below in the group is having the least ionization energy, while the one in the up in the group is referred to have the highest ionization energy. So this ionization energy are, so we can have elements. We have the first ionization energy, and then the second ionization energy. So this is the second ionization energy and the first ionization energy values. So we are going to have the first 3 elements which we are studying them at this level. So we are going to have the first ionization energy, and then we have the second ionization energy. So for the first element, which is beryllium, so beryllium, and then followed by magnesium, then followed by calcium. So here we are going to have 3 elements, and these 3 elements are the most important one. We are studying them at this level. So the first ionization energy for beryllium is 900, and in the first ionization energy for magnesium is 740, while for the last element, which is calcium, is 590. So learners, as we realize, as we move from beryllium to calcium, there is a lowering of the ionization energy. So we shall have for the first element 900, which is more than 700, and 700 is more than 500. So the least element here that is having the lowest ionization energy from these 3 elements is calcium, and the one with the highest ionization energy is beryllium. So here also we are going to see the same thing with the second ionization energy. So the first element here, beryllium, will have 1800, while the second will have 1450, and the last one will have 1150. So in this case, we have seen that the ionization energy decreases as we move from top to the bottom of the group 2 elements. So the group 2 elements are representing the ionization energy, the drop in ionization energy as we move from top to the bottom of the group. Now we are going to see the chemical properties. What are the reactions of these elements with the other elements or with other solutions? So we are going to see that this ionization energy is very important when we are dealing with the reactivity of the elements. We are going to see the first reaction here is the reaction of magnesium and calcium with air, that is oxygen. So we are going to see the first reaction here is the reaction of magnesium and calcium with air. So learners, we are going to see this reaction, what happened exactly when these elements are exposed to air. So we are going to have that the first magnesium, which is, we are going to leave beryllium because it is the smallest element in this group, and it has the highest ionization energy, the highest electronegativity, and more others. So it means its chemistry is a bit different from the rest of the group. So we are going to start with magnesium and calcium, and we see their reactivities. So in this case, we are going to see that magnesium burns readily with an intense white flame to produce a white powder of magnesium oxide. So magnesium, when it reacted with the air, it will form magnesium oxide. So we are going to have this representation with a chemical formula plus oxygen, and we are going to have magnesium oxide. So here we remember how we write the chemical equations. So we start with the reactants, and then we get the products. So here we're going to have to know which one is, or what is the physical state of each atom. So here magnesium is a metal, and we represent it by S, which is a solid, and oxygen is a gas, and we represent it by G. And we're going to see that magnesium oxide is a solid, so we have to put it inside a bracket, and this will show that this is the state of these atoms. So magnesium, when it reacted with the oxygen, it formed magnesium oxide in this form. So learners, we need to know that we have to balance the equation whenever we are dealing with chemical equation. So we see that this equation is incomplete because it is not balanced equation. So we have to put 2 as the subscribe outside magnesium oxide to show that magnesium is 2 atoms and oxygen is also 2 atoms. So in this case, we balance also the left hand side of the chemical equation. With this, we know that this is a full chemical equation, which is representing the chemical reaction of magnesium with oxygen. So this magnesium oxide also may be exposed to water, and this will show that magnesium, when it reacted with the water, it will give us magnesium hydroxide. So we are going to see that magnesium oxide. So magnesium oxide, when it is exposed to water or put inside water, and then it is dissolved, it will give us magnesium hydroxide. So we shall have magnesium hydroxide as the product. So here this magnesium hydroxide is an aqueous solution, and we have to put it inside the bracket to show that this is an aqueous solution. So liquid here, water is a liquid, and this magnesium oxide is a solid. So magnesium oxide, when it is dissolved in water, it will form magnesium hydroxide solution, which is in aqueous form. So we go ahead and we see the reaction of calcium with oxygen. We are going to have the reaction of oxygen with the calcium. So the same thing will happen, but here we are going to see that magnesium is a bit reluctant to react with air. So we are going to have an equation to show this. We are going to see that magnesium, so we need to remember this magnesium hydroxide, when it is exposed to a litmus paper, or when you dip a litmus paper inside this alkaline solution, of course it is an alkaline solution, it will turn the red litmus paper to blue. So here we're going to see that red litmus paper turns to blue. So this will show that this is an alkaline solution of magnesium hydroxide. So we are going to have also calcium. When it reacted with the oxygen, it will give us calcium oxide. Although the reaction is a bit reluctant, because the oxide coating but then bursts into an intense white flame to form a white solid of calcium oxide. So this calcium oxide is a solid, and this a gas, and here we have calcium as a solid. So this reaction here is, we are going to have that oxygen, here we have two molecules at the reactant side, and we have one molecule of oxygen at the product side. It means we need to balance the equation. So we are going to have 2 for the product side and also 2 for calcium to show a balanced equation. So this calcium oxide can be exposed to water and it will form an alkaline solution of calcium hydroxide. So calcium oxide, the same thing with the magnesium, it forms plus water, which is a liquid, it will form calcium hydroxide. So here calcium hydroxide is an aqueous solution, and it also turns litmus, it turns the red litmus paper, red litmus paper to blue, as we have seen with magnesium hydroxide. So learners, we need also to see whether this equation is balanced or not. So we are going to know that whenever you have a balanced equation, that will be the correct writing of a chemical equation. So we are going to have calcium, we have one atom at the reactant side, and there is also one atom at the product side. So hydrogen, we have 2 atoms at the reactant side and also 2 atoms at the product side. Oxygen, the same thing, 2 atoms at the product side and then 2 atoms at the reactant side. So of course we add this oxygen and with this atom of oxygen to give us 2. So this is a balanced chemical equation. So we are going to see that due to the oxide coating on the metal surface, it might be not very clear to see the trends of the reactivity of the alkaline solution. As you have seen that with the oxygen, calcium is a bit reluctant to react with it. Why? Because there is an oxide coating at the surface of the metal that makes them to be reluctant in reaction with any other reagent. So in this case, you will see that the reaction is a bit slow, but after removal of this coating, it will become a bit faster, or it will be a vigorous reaction. So however, the reactivity increases as you move down the group. So With the group 2, we are going to see that the reactivity increases as you move down the group. It means those elements below in the group are very reactive compared to those ones above in the group. So the reactivity of group 2 increases down the group, and this showing that beryllium is less reactive compared to magnesium, and magnesium is less reactive compared to calcium. So we are going to see that although this reactivity is increasing as you move down the group, but we need to remember that there is a coating that is being formed upon the surface of the metal. So this will make the metals not to react so quickly as we should have expected. So in this case, we need to remove the coating out from the surface of the metals, and in this way we shall have the reaction of the metals, either beryllium, calcium or magnesium, with any other reagent so quickly. So we are going to see that due to their reactivity nature, group 2 elements react with the air to form a dull coating. So it means this coating, which is covering the metal surface, it is formed from the oxide. So it means if you keep these metals outside for a long time, it will form a coating around the surface. So learners, we need to remember that this coating is caused by the presence of oxygen in the air. So it will cause the coating upon the surface of the metals and causes the slow in the reactivity of group 2 elements. So group 2 elements are actually, and we know that they are very reactive compared to the rest of the elements in the group or in the periodic table. So the most reactive elements are those ones at the left hand side of the periodic table, and the less reactive ones are at the far right hand of the periodic table. So it means here we consider them as the electropositive elements. We consider them as the electropositive element. Why? Because they lose electrons, and as they lose electrons, they form a positive ion. So this positive ion will have a charge which is showing the outmost electron that has been lost during the formation of the compound or ionization of group 2 elements. So we need to remember that the reactivity of group 2 is a bit slow, but although it is increases as we move downward due to the formation of the coating upon the surface of the metals. So learners, we need also to know that the ionization energy is very important when we are dealing with the reactivity of the elements. That is why we say that the ionization increases as you move down the group. So the one with the less ionization energy appear to have a very higher reactivity, and the one with the higher ionization energy appear to have a low reactivity when they are exposed to any other reagents. So learners, we need also to remember that the group 2 elements, they are not only these three, but these three we are just learning them to also to show or to represent the other group or the other members of the group. So we need to put into our mind that the group 2 elements, they are referred to as the alkaline as metals. So also we need to know that the reactions are very important for us to know, because these are our usual elements that we deal with in our daily lives. So we have to come into this, and we are going to see that some other reactions as we come for our second lesson. So we are going to see the other reactions of these elements with some other reagents, and we see how their reactivity is going to take place. So we are going to see that a litmus paper here is very important. It will show us that whether this reagent or this product form, is it really an alkaline solution, an acidic solution, or it is a neutral solution. So when you dip a litmus paper, whether it is red or blue, it will show will show whether this reagent is, or this product form, is an alkaline solution or a basic solution. So we are going to, or an acidic solution. So if you have this solution, or the product form is acidic solution, it will turn the blue litmus paper into red. So if it is an alkaline solution, it will turn the red litmus paper into blue. So the color of the litmus paper will turn from blue to red. So learners, we have come to the end of this lesson, and we have known that the ionization energy drops as we move down the group, and the reactivity increases as we move down the group. So till we meet next time, thank you very much for listening. So we shall meet at the next lesson, and we are going to see the reactivity with the other reagents. Thank you for listening once more.